Hey, Mr. H back with you for part 2 of graphing logarithmic functions. So before we talked about logarithms and exponentials, how to transfer them from one to the other, how to do inverses with one to the other, how to kind of solve or simplify logarithms. Now what we're going to do is we're going to take it a step further, okay? We found out that logarithms and exponentials are inverses of each other, okay? Take a log, you do the inverse, it becomes an exponential, and vice versa. That's an important thing to remember. Okay, they're inverses. So all properties of inverses still apply. You're like, wait, so even like graphically it does? Let's see. So if we go to here and we do 10 to the x power, okay, and I'm going to pull the chart first. I'm not going to worry about this other stuff yet. So I'm looking at some values here that might be able to get on here. And I notice a couple of things. So I'm going to jump to the middle here. So I'm going to do negative 2, 0.01, negative 1, 0.1, 0, 1, and 1, 10. Okay? So when I actually look at the graph, you're like, oh, it's just a growth function. It goes up to the right. Right. So, but as we've talked about before, it gets really, really close to 0. But remember, e is like really, really close to 0. I showed you all that 0.00000 thing before, but it never quite gets there. So we're going to hug the axis, but we're not going to touch it. Okay, so I get that graphed. So let's take a look at some things. Okay, we've got a y-intercept. Okay, a y-intercept at 0, 1. For us to have any intercept, you have to have a 0 either on x or a 0 on y. So we'll take note of that here in a little bit. Okay, my asymptote, remember, my asymptote is my do not cross. Like I get really close to, but I never go over it line. And that's at y equals 0. Okay. Our domain, as we said before when we were doing our growth and decay functions, forever left, and this is continuing to stretch out forever right. Our range is going to directly connect with our asymptote. That asymptote's telling me where the lowest part of my range is, okay? That y equals 0. So 0, parenthesis, because we never get to 0, but we get close, to positive infinity. And we're going to make a little note here on range. Moves with up or a down shift. We'll get to the shifts in a little bit. So just, that may not be useful for the moment, but oh, it's going to be here soon. Okay. So now why I put this on here twice, I couldn't tell you. Couldn't tell you. So we're going to ignore the second half of that one here because we already did the domain and range and all those things. But now we're going to graph log of x. So we're going to clear this one for a minute. We're going to put them on together momentarily, but for the moment, let's just look at it by itself. So log of x. Now let's think about this for a minute. When we were graphing before, okay, let's pull our chart. So now this time, here's the deal. Here's 1, 0. You're like, okay, I see that, Hardy, but hang with me. 10, 1, okay? You're like, okay, but I don't see the other ones. Now remember, we can look up any point by hitting the trace button. So if I hit trace, and I hit 0.1, because remember, x and y swap on an inverse, I'm willing to bet you negative 1's going to come up. Oh, amazing. You know what I'm thinking, right? Trace. Again, I'm just changing the x and y values. They're all swapping. 1 and 10 swapped. 1 and 0 swapped. 0.1 and negative 1 swapped. And yes, you know it, negative 2 and 0.01 swapped. They're inverses. Another way I can show you that they're inverses. Let me do this for you. Let's pull this back up. Before, when we were graphing, we said that we would be able to see a reflection. Now this doesn't stop here. It continues all the way down this axis. So if I took the line y equals x and put it down the middle, we chatted a little bit about this with our inverses before. That's like my fold line. If you folded your graph along there, those graphs would be on top of each other. Okay, so this graphically shows that they're inverses. We algebraically showed last section. Now we're graphically showing. Kind of cool. So what does that mean for us, though, with our other information? So I'm going to clear this other stuff out. Okay, bring this back up. So intercept. Let me pull my chart back up here. My intercept's at 1, 0. Okay, so here it's a little bit different. Oh, I didn't graph it, did I? Hardy. I get so excited sometimes when I'm going with this stuff. I'm like, look at all these connections. And then I'm like, oh, it probably would help you, dude, if you actually graphed the line. But like I was saying, we're hugging the y-axis. And I know it looks like it stops there, but it doesn't. It just gets so close to the axis that, I mean, that's really close, that we don't see it. So my asymptote is going to be going this way. When I'm doing a logarithm, my asymptote goes along the y-axis and is at x equals 0. So let's kind of start looking at some comparisons here. Over here, we had a y-intercept. Now in this one, we have an x-intercept. That's not coincidence. Move myself out of the way here. Okay. My domain is not infinite this time. My domain, notice how the asymptote is x? Well, so is my domain. So my domain goes from left to right. Whatever your asymptote variable is, that's what y goes with range, x goes with domain. And now my range down forever, and this is slowly going to creep up forever. Again, that never changes on these. So you start to see what's going on here, how these connections are going to go. And with domain, that's going to move with a left or right shift. And we'll talk about those as well. So exponentials, this information is our base. Logarithms, its inverse, this is our base. So how's that going to work with what we do? Glad you asked. So I get to this logarithm, okay, x plus 4. First thing we want to check out with this. You're like, no. For those of you that had me first quarter, how many times did we see this H and K thing? Like a bajillion. We saw it with what? Quadratics. We saw it with square root functions. We saw it with absolute value functions. Now we're seeing it again with logs. So reminder what all these things mean. The value in the parentheses is my left or my right shift. But with that minus there, it's the opposite of what we would think. My K is my up or my down shift, but it goes traditionally with what you would think because of the plus that's there. So first thing to answer here is my transformation, my shift, here inside and plus is going to be left 4. So what does that mean? Okay, if I pull this back down for a minute, if there's a left or right shift, my domain moves and my asymptote moves. So let me show you that on the calculator, and then we'll discuss why that is. So we'll jump in here, x plus 4, graph. Notice my graph is starting over here. If I look at my chart, where does the error message start? That's where my asymptote is. If I want a little extra help, my asymptote, oops, not y, Hardy. This is not a growth function. is at -4. My domain, therefore, starts at -4. There is always going to be a relationship between those two values. Okay, asymptote and domain. Range, we said it before, we don't care. I don't care what direction you shift things, that's going to be infinite. So here, a few things I can do before I would start graphing. I would draw my asymptote in, and it's always a dotted line. And that just lets me know my graph's not crossing that line. So I got -3, 0. Do I get any more whole number points? I might. Oh, there's one more. 6, 1. A lot of times you're not going to get a whole lot more than that. And again, when you're graphing, curve and hugging the asymptote, don't go through it though, it's the do not pass line, and reset. Okay? So really it's just a couple of points, and otherwise use your shift to know where your asymptote and domain start and the range is the end. That's it. And yes, is that going to be different if it's natural log? No. Okay, transformation. Right to, still inside, the opposite of what we would think, which means my vertical asymptote, vertical, is at x equals 2, which means my domain starts at 2, and my range is infinite. Notice I didn't even pull the graph yet. I can get all that information. I don't even need the graph. It's kind of cool. So let's go in here. Let's use the natural log of x minus 2. Take a peek at the graph. I can see my shift to the right. There's the error message at 2. So let's see. Get my asymptote in there. 3, 0. Do I get one more point? Am I going to have to stretch this a little bit? You're like, okay, Hardy, what if I don't get a second point? What should I do? What I'll usually do then is I will go to the largest value that I see that's on my graph at 10. So it's a little above 2. So I'll just go a little above 2. All the other rules apply. We're just doing sketches. Okay. I want to see approximately some good points. I don't want you just doing roar on every single one, but as long as you especially get that intercept in there, we'll be good. Okay. Other things to be careful of, again, not hard. Be careful. The 5's not in parentheses. What direction are we going? Down 5. Ooh, now be careful. Does that mean my vertical asymptote's going to be at 5? Well, Hardy, why not? Because our asymptotes on logs only move with left and right movement. Up and down is for when we're doing our growth and decay functions. So down 5 means my vertical asymptote is not moving. It naturally is at 0. We're going to look at it on the graph in a minute. My domain always goes with my vertical asymptote, and the range just doesn't care. It's going to keep doing what it does. So let's see here. Log. I find the log button. There it is. X. Make sure you close the parenthesis this time. Otherwise, you're going to be in for a surprise. Okay. It moved down, but it's still, where's that first error message at? 0. Okay. So 1, -5. Oh, I got to put my asymptote in. I still should do it. And then again, if I don't get another whole number, ooh, I did. 10, -4. And just don't cross the asymptote. Okay. So again, we've discussed most of this on the way through, but we'll kind of see here. Okay, transformations, we talked about them. The H value is my left and right shift. It's the opposite of what I would think because of the minus there. My K is my up and down. Exactly what we would think it is. Vertical asymptote. Now, that's going to depend. Okay? It's x equals 0 unless there's an h value. In other words, unless you're moving left or right, that vertical asymptote's not going to move. Okay? So then your domain technically would be h to infinity, because whatever my h value was here is going to match here. So when we had the numbers, if my h value is 5, if this is 5, this is 5. This is -3, this is -3, and so on. And my range is always infinite. And so your job is going to be to do some practice ones. I will let you see a couple of them up here at the top from the key that I'm working with. Oh, I don't want to see all of them. Now, I know it says graph aggregate by finding 3 points. Okay, let's try to find 2. Okay, if you find 3, that's great. But otherwise, 2 is perfectly acceptable. And again, just remember, your left-right shifts, I know it doesn't ask for you to do the transformations. I would, though. I would be like, okay, this is left 4, up 5. That's the number I care about. Okay? Left 4, domain, range doesn't change, and play it. Okay? We'll be seeing more of this. We're not done with the whole log thing yet. We've got a little time here, some more algebra type stuff to do with them next. So as always, let me know if you got questions, and we'll see you next time.